So 0.901, 0.902, 0.903. We're doing probability section. 0.904, 1, 2, 3, 4, 1, 2. Here's 1, 2, 3, 1. So these four cancel out these four, so it must be D. Clearly, it must be D. Over here, this is the most, so it must be C. With that, let's just finish this up. This is going to be weighted average. So basically what you have, summation Wi of x and summation x. X is the frequency, so whatever frequency, just grab your calculator, which in my case, I should show it off, is this one over here. So let's first add up the bottom, which is 25 plus 35 plus 40 plus 55 plus 21, which is 176. So the bottom is 176. Next thing you have to do is multiply each other. So 25 multiplied by 2500 multiplied by 25, and so on and so forth. Multiplied by 25 plus 2550 multiplied by 35 plus 2600 multiplied by what again? 40 plus 2650 multiplied by 55 plus 2700 multiplied by 21 divided by 176 equals 173. So it's about C, I think. Well, for some reason, my calculator shows 2603, but I think it might be a rounding error from the uh, question itself, and we'll double check the numbers. Yeah, I don't see a mistake in my numbers, so it must be a rounding error that they created. Okay, so this one I kind of a little bit cheesed on how I did it. Because I was thinking if this is a mistake, the next one will be a mistake, and so forth, so forth. So I had to double check with Desmos. I could use my hand calculator, but I wanted to make sure I can visibly see it. And yeah, they are not the correct numbers. I don't know what's going on. The closest one, I think it was like a maybe a continuous error. So maybe they did 602 instead, and then that 602 carried over here, and they compounded the error because the actual answer, as you can see, is about 62.3. I know. I didn't really do the exact number, but come on, 3 digits won't change much, right? I'll double check for you guys. Yeah, it didn't change much. It's definitely a number error. So it should be 62.3. I don't know why it is 61. I don't remember where I cut off, but basically what you do is go to your handbook and figure out this equation over here, this one, and then just use it. And then you get that answer. And as you can see, that's kind of what I did. I don't understand why there is a huge discrepancy over here. I'm expecting the same amount of discrepancy over here when we do this equation, which is going to use, which one was it? I already know what it is. It is, I should probably still show you where to find it, just in case you're going to use this. It's using a standard deviation. It's x. Why can't I find it on here? Ah, here it is. No, that's the other one. That's the one for the other one. Not this one. Yeah, you can't find it. If you find it, use it from here. I recommend you just try to find it. I think it might be similar to this one. I don't know where it is. I'm looking at it. Maybe I misplaced it. Um, but I don't think that's the right equation. The equation I'm thinking of is x equal, what was it again? X bar minus average divided by not average, but I mean yes average, but divided by standard deviation, and I don't see it here because that's how you do it. I can't find it, but I know I'm correct because this is how you do standard deviation talks in this stuff. Uh, ooh, I don't know. Maybe the n is no n is sample size, so that doesn't matter. That should not matter. Oh well, I have no idea where it is. But at least we know how to solve it. So since we know what we're looking for, which is two below 1255, so 2550 is here minus the average, which is this again, minus divided by this. Oh, is 0.8. Anyways, 0.8. So in this distribution form, it's about 0.8 over here negative. So in that sense, it's going to be this area over here and the percentage wise. So how would you get that? Well, you have to look at the P graph from here and look at this one would work. And you're looking for, once again, 0.8, so 0.8, so 0.2, so it's about 21%. 20%. The closest one here is gonna be 16. So I'm gonna say B, but it's more close to 20% about. I don't know why such a wrong answer, but there you go. Yeah. Okay, here it took me a little while for me to get this, but first thing we need to realize is what this implies over here. So we need to attempt three heads and then one tail. So here's the thing. It asks for the probability, not the permutation or whatever. So here's the thing about permutation and combination. It tells you the amount. It doesn't tell you the total. What confused me is because probability and permutation use the same p. So uh, once I refresh myself a little bit on the um, statistics, you find that how you do it, because it's the combination that matters, which is n and then r, which is basically saying c parentheses, I believe it is four total, three. So that would be 4, 3, this format in what was it called again? What did they call it again? In the notation in binomial theorem notation. So in that binomial theorem notation, this 4 and 3 equals n and r, which then gives you equal to 4i, 3i parentheses 4 minus 3 is 1i, which is this. Let me grab my calculator. I don't think it has exclamation mark. I've been looking for a while, but I haven't been able to find that. So I'm assuming that I have to do 4 times 3 times 2. So 4 times 3 times 2, and then 3 times 2 times 1. Cancel that out. That equals 4. I'm being lazy here. So the number of permutation here is equivalent to saying 4 for this question. Okay? So if that's 4 on the top, what's the total amount of combination there is? So think about it. There's a half, and there's a half, and there's a half. There's 4 coins, right? So there's 4 chances for this to happen. So it's 2 parentheses by how many? It is 2, 2, 2, 2, 2. So it's 4. So this the probability is 2 choices and a half, and then you quartize it. So it's 4. So 2 times 2 equals 4, and 4 times 2 equals 8, and 8 times 2 equals 16. So that equals 1/4. Boom. So 1/4 A. Okay. That makes sense to you all? Now let's go to over here. This is saying there's two students are working independently on the problem. Their respective probabilities to solve is this. What's the probability of at least one of them solving it? So this is also going to this handbook, and this is why it infuriates me a little bit over here. So we have to go all the way to probability. You see how the P is still used the same way? So there needs to be a better notation for permutation, honestly. What are you thinking? So here's the general law properties, and the one that you need to know is the total probability of A plus B is equivalent to saying probability of A plus probability of B and minus probability of A comma B. Now, a long time ago, I would have told you guys, told I need to prove this, I need to figure this out and figure out how to do this. But nowadays, I'm just saying we're engineers. I've realized some proofs are not needed to prove. Although some proofs are wonderful, this is not one of them. This is a minus. So we will use proofs in a way that solves problems, but we'll never use proofs in a way that makes our lives um, ask ourselves why we're doing this, basically. So that equals equivalent to saying 0.8333 bar, which is 5 divided by 6, according to my trusty dandy calculator. I should probably show off my calculator a little bit. There you go. My calculator says that. Okay, so we have our answer as D. And moving on, we go to this section, the simple variance question. So the variance question, we also look at the handbook again. We're going to look at the handbook a lot. Very much is going to be our favorite dictionary for everything. So simple variance probably is what? No, sample variance. Sample variance. Okay, yeah. So this is s squared equal 1 divided by n minus 1 summation I equal 1 n xi minus x bar parentheses square. In this case, you have 3 minutes per question. So you go back here and take the average of it, say 2 plus. Oh, by the way, you don't have to time to double checks often, in my opinion. Some of these questions will take 3 minutes. So take it with a grain of salt. So 56 divided by looks like it's 1, 2, 3, 4, 5, 6, 7. So 7, so it's 8 equals x bar. Now we plug it back in here and we figure out what it is. So it is 1 divided by 6 instead. So if I do 1 divided by 6, multiplied by all the rest, which is saying something, 2 minus what is this? So let's just do it like this. 8 minus 2 equals 6, so 6 squared. And then 8 minus 4 equals 4 squared. And then 8 minus 6 equals 2 squared. We could maybe, but 8 is 8, so that doesn't really matter. Plus 10 minus 8 is 2 squared. And then here's 4. 4 is 4 squared. and 8 is about 6 square. And you parenthesize that, you get 56 out of 30, which is equivalent to say 18.7. Okay, so now we put that in here to say D. Oh, no, D. Also, bubble in your answers correctly. I mean, look at that. I could have bubbled it wrong and I could have fudged the numbers there. Yeah. Okay, what's next? The probability of picking up the orange ball and the white ball out of the bag contains, okay, 7 orange, blah, 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 blah. So we have orange, which is, oh, I dropped my calculator. We have 7, and it's divided by 8 plus 2 plus 7. So it is 10, 17. So 7 divided by 17 equals to 0.14. What did I just be wrong? What's the probability of picking an orange ball and a white ball out of the bag? Sorry, my apologies. It is 7 divided by 17 at first. But then we have to look at the next version. Wait, is it, yeah. Is it before or after? So it's a 7. Yeah, we're good. We're good. I think 7 and is divided by that. What is it? So it's like uh 16, right? White balls, how many? 2, so it's 1. Well, that's very small if I multiply those together. That should be good, although that should be correct, right? So no, something's wrong here. I think there is something wrong. Orange and the white is an or question. Because you initially have this, which equals what is it? Multiplied by 1 divided by 16 equals 0.2257 0. But you have to notice that no, that's wrong. 2. This is 2. So it's 2. Something was, in my opinion. 7 divided by multiplied by 2 divided by 16, right? And that's 0.205. All right, that's one of the things we have to look for. But then again, we have to look at the other way, which is saying when there was 2 out of 17 choices and then there was 7 out of 16 choices. So 2 multiplied by 17 multiplied by 7 divided by 16 is two different numbers. It's still 0.05, but equally is a probable chance. So you add those together, which is 0.1. So it's a B. They're equally valid branches in the equation. So that